Back at it again with kth largest element in array. We're going to start this one here. Not going over any of my old answers. So here we're going to, given an integer array nums and an integer k, return the kth largest element in the array. Notice that it is the kth largest element in the sorted order, not the kth distinct element. Can you solve it without sorting? Does a heap count as sorting? All right. Is it asking me to do it without sorting? All right, so go find the kth largest element. In the array. Duplicates count as individuals. So we're going to use a heap. So when we need to find the kth largest anything, we can use a heap or quicksort. Quicksort is a little wordy, a little involved, but that's going to give us the fastest runtime for these type of questions. All right, and then the questions we could ask is k ever greater than the length of our input array? If it is, what do we do? All right, do we treat it like as a circle? All right. Here's going to give us our constraints. Here's our constraints. So now we're gonna ideas. Whenever we need to find the kth largest anything, we're gonna use a heap or quicksort. Quicksort is better here, but again, we're gonna go with a heap because the implementation is easier. What are our steps here? Do you want to create a max heap or a min heap? I think we do a min heap, right? Min heap. In Java, min heap is natural order, so whenever you create an integer-based priority queue, it's automatically a min heap. So we'll keep a min heap, right? And we'll add k elements to it. We'll add k elements to it. Create min heap. Add k elements to it. Create min heap and iterate over the array. If the array, if the heap size is less than k, so create a min heap and add k elements to it. All right. And so let's say if we have 2 elements and our k is 2, we'll add 1 and 2 to the heap. The head of the heap, the root of the heap will be 1, which is the second largest value in the heap, right? And then we'll just return the heap. So we'll create a min heap and add k elements to it. So it went, all right, and then we'll do that in one loop, and in another loop we'll check if the current element is larger than the root of the heap, we're gonna pop it, we'll poll it, and add the current element to it. After we're done with that, we're just gonna return the head of the heap, right? And that's gonna give us a time of O of n log k, where k is k and n is the length of the array. We need to iterate over the entire nums array to find the kth element, and every insert into the heap is going to be log of k, and then our space is going to be equal to O of k. All right, and technically, since the time is O of n log k, that would be faster than sorting, because sorting will be O of n log n. So technically we're not sorting, right? So we'll create our priority queue here, and that's going to be an integer. Right, and that's going to be a natural order. For int I is equal to 0, I is less than k, I plus plus, and then we're going to do pq.offer nums I, and then for int I is equal to k, I is less than nums.length, I plus plus, if pq.peak, I think it is less than nums I, we're gonna pq.poll, and then pq.offer nums I, else we continue. And then here we're gonna return pq.peak or pq.poll. All right, and that's gonna give us the kth largest element. So what does that look like? So we're here. We're gonna do this quick dry run. So our input is here. We want our output to be 5. So I is gonna be equal. So let's add our first two elements. So our priority queue is gonna start off as, we're gonna put 3 and 2. So our priority queue is gonna be 2, 3, right? And then we're gonna iterate from k to n, right? So k is equal to 2, so now we're at 2. Index, element, min element in heap. Right, so our index is going to be 2, our element is going to be 1, our min element in so we'll just call this heap. So our heap is going to be pq is it's going to be 2, 3. 1 is less than 2. We're going to continue. We're going to go to 3. Element 3 is 5. So our heap is now going to be 3, 5. All right, because we're going to pop it. Let's call that result. Skip 1. So we're going to pop 2 and add 5. 3 is new head. 4 is going to be element is going to be 6. So now our element is going to be 5, 6, because we need to pop 3 and add 6. 5 is the new head. 5, it's going to be element 4. Our heap is going to be 5, 6. We're going to skip 4. That's going to be end of our loop, and then we're going to return 5. And make sure nothing is wrong here. 41 seconds. Lord have mercy. 41 milliseconds, I mean. What is counting sort?